We're going to be talking about line of best fit and regression line. This is like the last little bit of the statistics part, the statistical applications part that you guys will learn about. So you're going to learn how to find the prediction line. Find the prediction line by hand and also by your calculator. We kind of mentioned this already because someone asked me, are you going to have to learn how to find the trend line when it comes to your data? And I said yes, and that's what today is about. So we're going to do the line of best fit, which is what you do when you do it by eye. And then the regression line is actually what it's called when you do it using your calculator. So if there is a strong linear correlation between two variables, we draw the line of best fit to illustrate their relationship. It is only when you have a strong linear correlation. So if it's moderate or weak or anything like that, we do not usually find the line of best fit, okay? I mean, we can, but it's because it's such a weaker correlation, it's the predictions that we use the line for are not going to be that good, okay? Remember, make sure you're taking smart notes. Make sure you're taking smart notes. There are 3 steps when it comes to drawing the line of best fit. Remember, this is the one that you're drawing by eye. You want to calculate the mean of your x and your y values separately. So you find the mean of your x's, you find the mean of your y's, and then you want to mark that mean point on your actual scatter diagram. Okay, then you want to actually mark that point on your scatter diagram. How you mark it, okay, because you do need to distinguish it from your other points. So when you plot the mean, you put the point, you circle it, and then you label it. Normally it is with an M, but depending on the problem, sometimes they'll say label it with P, then of course you label it with P. But the distinction is that you circle the mean point, okay? And then step 3, you draw a line through the mean point so that it fits the trend of the data. What that means is you want to make sure that half your data is above the line and half of your data is below the line. And that's what I mentioned the other day when it came to drawing that trend line. You want to make sure that half of your data is above the line and half of your data is below the line. You want to make sure that your line intersects the y-axis. Okay, you want to make sure that your line intersects the y-axis. So even if your data is focused only on the first quadrant, you still want to draw your line so that it intersects at some point on the y-axis, even if it could potentially be below the x-axis, okay? Like I said before, the line of best fit is used to predict values for one variable for a given value of the other. If we predict the y value for an x in between poles, okay, which basically a pole is created from your lowest point and then your highest point. If we predict a y value that's in between those poles, it's called an interpolation. If it's outside of those poles, it's called an extrapolation. So your poles are created once you have your scatter plot, and then you draw your line of best fit. Whatever your lowest data point is and your highest data point, you basically create your poles. And then anything in between is interpolation. Anything outside is an extrapolation. So basically what this means is that this line is used for predictions. This line is created based off of your data. So when you're asked to do predictions within your data, within that interpolation, that means it's going to be a really good prediction because the line is based off of that data. But once you go outside of those poles and you enter into that extrapolation, that's when your predictions start not making sense in context of the problem. Okay? That's when it stops making sense, and the validity of it basically isn't valid. And I have an example for you on the next page. Okay? So if anything, if you're asked to use the line of best fit to make a prediction and it's within the interploitation, then you know it's going to be a good prediction. But if it's outside of the poles and it's in that extraploitation area, then it is not going to be as good of a prediction. Okay? And this is what I mean by it. Going back to that, the distance of the throws and the ages, right? All of this was our data right here, okay? But this is your line of best fit based off of that. The red point indicates your mean, and then this was your line of best fit, okay? This first red line was basically asking, okay, someone who's about 14 years old, how far can they throw? Okay, well, you go up from the 14, see where it hits your line, and you can see that they throw about 26 meters. Okay? But if I were to follow, and as you can see, it's inside of your data. It's within your pulse. Okay, it's interploitation. That's a good prediction. But if you were asked, okay, well, how far can a 50-year-old throw? Well, according to my line of best fit, you're telling me that a 50-year-old can throw 144 meters. The world record is 76 meters, so do you get what I'm saying? Once you go outside of the poles, basically the validity of your response is, you can see, is not valid. That makes no sense. If the record is already 76, how in the world can they throw 144?
So would you still just put the 144?
So to answer the question, you would put, 144 meters. But if the question asks, is it a valid answer? Can you interpret that correctly? Does it make sense? You would say no, because it's an extraploitation. It's outside of my poles. But the one for the 14-year-old is within, and that's a good prediction. Question?
What was the interpolation and extrapolation?
So it would be based off of the lowest value. So then it would be from about 10 to about 20. So these would be your poles. So anything in between 10 and 20 would be a good interpretation of that. So a 14-year-old, a 17-year-old, you can make a prediction there. But once you go outside of that, it's not a good prediction. This right here, if it's an 8-year-old, an 8-year-old should be able to throw, 2, 3 meters, okay? A 6-year-old can't throw at all, so you tell me they can't even pick up a disc and throw it. You see what I'm saying? So within the poles, good. Outside the poles, not good. Enter, extra. Good? Okay. Let's look at an example. On a hot day, 6 cars were left in the sun in a car park. The length of time each car was left in the sun was recorded, as well as the temperature inside the car at the end of the period, A, B, C, D, E, and F. We have to calculate, write this in, X bar and Y bar. What do those mean?
Mean.
The mean. I need to find my mean time and my mean temperature. I want you guys to do that now using your calculator. What was the mean for your X's?
30.
30, and your Y's?
38.
Okay. Now we're going to draw a scatter diagram for the data. I provided a centimeter paper for you. Okay, so I didn't put it in here. Let's do our X's. 2 centimeter represents 10 minutes. 2 centimeter represents 10 minutes. And on our Y's, 2 centimeters represents 10 degrees. 2 centimeters represent 10 degrees. Go ahead and plot your data. All right, so roughly your graph looks like this with your points. Okay. Let's recap a little bit about what we did in last class. How would you describe this correlation? Positive, strong, and potentially no outliers, correct? Okay. So that's part B. Part C asks us to draw the line of best fit. Now remember, to draw the line of best fit, you need the mean point. You guys said the mean of your X's and your Y's was
33.
So I plot that point 30, 38. I put the point. I need to do what with that point? And then label it, right? Okay, make sure you label it. And then I'm going to draw my line of best fit, making sure it passes through the mean. And it's half and half, okay? Use a ruler here. Nothing wrong with using a ruler. If you don't have a ruler, you can borrow one. If you want to use the side of your calculator cover, you can use that too. You just need a straight edge. So you want to make sure that it goes through your mean point. About half of your data lies above the line, half of your data lies below the line. For me, it looks like 2 are about on it, and then 2 are above and below. And I also made sure that my line crossed through my y-axis. So make sure your line crosses through your y-axis. But definitely for sure the mean. Okay? Definitely for sure the mean. Now make sure you commit. It is like one line. Don't do like the shading over the line thing. Okay, one solid line. Okay, you know, let's talk about smooth curve, smooth line. Okay, you good? Okay. So now we want to predict the temperature of a car which has been left in the sun for 35 minutes. So 35 minutes. Does that lie in between my poles? Yes, it does. So that means the prediction of a car that's been in the lot for 35 minutes is probably going to be a pretty good prediction of the temperature. So I'm going to go ahead and go at 35. It was 35, right? Mm-hmm. Going to go at 35. I'm going to go up to see where it hits my curve. And then from there, I'm going to go over. So based off of my line, the temperature of the car should be about 40.5 degrees. Based off of my line. Okay? Similar to what we did with cumulative frequency curves. So I'm going to put, for me, 40 degrees Celsius. What are some of the things that you guys got? 40, 41? 39? Okay, that's not far off. We shouldn't have anything too crazy, though. If we do, that means your line, you might have drawn your line a little weird, okay? Yes?
Should we just put an exact value, or should we put like a squiggly equal sign?
It will be an approximation. Now, the next question says, predict how long it would take for a car's temperature to reach 55 degrees Celsius. Okay, there should have been a degree Celsius there. So now I do the opposite, and so this time I'm coming from the y-axis. Oh, geez, so I'm going to have to extend this a little bit. Let's extend this. Yeah, I know. Oh, man. 55 would be somewhere up here. It's actually about the same spacing. For me, I would say it would be about 60 minutes for the car having sat out there to reach 55 degrees Celsius. Comment on the reliability of your predictions for D and E. For D, reliable? For D, it is reliable. Why? And you can and leaving it just like that suffices. It's an interpolation. What about for E? E? No, because it's an extrapolation, and that suffices. You just need to be able to recognize that it's in between the poles and not in between the poles. And that's how you draw a line of best fit by eye. And answer questions and make predictions. Now, what do you think are some negatives about drawing a line of best fit by eye?
It's not very accurate.
It's not very accurate, right? And depending on how I draw my line versus how you draw your line, that's going to be some issue, okay? Just like when we are describing the correlation, and we're trying to determine, for some people it may be strong, for other people it may be moderate, okay? But just like how there's the correlation coefficient to find numerically an accurate representation of the correlation, there is one for basically your line of best fit, and it's known as a regression line, okay? So because the line of best fit varies from person to person, a more consistent method that is used is called a linear regression, and this is done with our calculator. So we're going to look at the last example, the example that's on the back of your paper I gave you, and we're going to do this one using our calculator. So looking at the last example, it says the annual income and average weekly grocery bill for a selection of families shown, and we want to use technology to find our regression line. So since we're using our calculator, we want to make sure that we enter in our data. Where do I go on my calculator to enter in my data? I go to Stat, I go to Edit, and then I have to type in what, where?
And first you have to make sure it's clear.
I got to make sure my tables are clear, very good, and once I clear them, in L1 is going to be my X, and my L2 is going to be my, how do I clear my data? Go up to L2, click clear and enter, go up to L1, click clear and enter. So now I got to type in my data. All right, so once I have my data in, I need to get the equation for my regression line. Now, to get my equation for my regression line, it was the exact same method I got my correlation coefficient. You guys remember how we did that? Okay. I'm going to quit out of this. Where do I go to get my correlation coefficient? Stat, Calc, option 4. That LinReg stands for linear regression. So where we went to get our correlation coefficient is exactly where we go to get our regression equation. So I go to option 4. Again, I make sure L1 and L2 are good to go. And because I'm going to be doing some more stuff with this, let's go ahead and store my regression equation. I went over it very quickly the other day. I'm going to go through it slower here. I go to vars, under store regression equation, I go to vars. I go over to yvars. I go to option 1, which is function. And I go to y1, which is option 1, which is y1. So I'll do that again. Under store regression equation, I hit vars, yvars, function, y1. And what that's going to do is it's going to store my regression equation into my y1 of my calculator. Okay? So then I go down to calculate, just like I did before, and click enter. And that y equals ax plus b. Sound familiar? Like y equals mx plus c? Yep, that is your equation. Your a is given to you, your slope, and your b, your y-intercept, is given to you. And you round that to 3 significant figures. So what's a? So 4.18x. And what's b? And then that's my b. So that is the equation for my regression line. Okay? It's the equation for my regression line. Questions on that? Now it says to state and interpret the gradient of the regression line. I haven't used that word in a long time. What does gradient mean? It means slow. So you have to state what it is, and you have to interpret it. So let's state it first. What is it? It's 4.18. And when it asks you to interpret, it means in context of the problem, what does that mean? Okay. Yes. Be specific. What is X and what is Y? So as income increases by how much? By 1 or? So as income increases by 1,000, because this is in thousands, technically this is 4.81 over 1. Remember, rise over run is slow. Okay? So as income increases by 1,000, grocery bills increase by 4.18 pounds. Okay? So when you interpret it, you're doing it in context of the problem. What does X represent? What does Y? As your X's are changing, how are your Y's changing? Questions? The only reason why we're using 1,000 for my X is because that was the conversion for my X's.
Wait, is it just because it's the slope that it affects it affects the Y, the grocery bills?
Well, remember, slope is the change of your Y's over the changes of your X's. So yeah. So as my income increases, well, it's supposed to be as my income increases, I should be able to afford more groceries. That's how it's supposed to be. All right. We're going to estimate the weekly grocery bill for a family with an annual income of 95,000 pounds, not dollars, pounds. Okay? So we're going to do this one of two ways, because we have the equation already written out for us here. And if I'm trying to find my weekly grocery bill, am I looking for X or Y?
Y.
I'm looking for Y. When X is what?
95.
Is it 95,000 or
95.
it's 95? Because remember, X is in terms of thousands. So I can work this out by easily just plugging in 95 for X and solving. What did you get? 340. So then three significant figures would be 340 pounds. Okay? Now, you can do this algebraically. This gives you your method. There's your answer. Okay? This lets the grader also know that you're using the equation, so you are using the rounded answer. You can also go to your calculator. Okay? You can also go to your calculator. If you go to y equals, you see there's the equation that we stored in there, the full equation. And if I go to Zoom 9, there's my data, and there's my regression line. I can actually use my regression line on my calculator to get a more exact approximation for 95,000 pounds. Okay? The only issue is that when I click on window, my X's only go up to 67.9. I'm trying to plug in an X value of 95, right? So I need to adjust my window so then that way I can see it. Does everybody understand that? Yes. Okay, so if I wanted to, I can adjust my X max to, let's just say 100. So when I graph it, it opens it up a little bit wider. And that kind of also lets me know that 95 would be an extrapolation. So then I can go to second trace, option 1, and then I can type in 95. That's another option that you could do. Okay, so second trace value, and isn't that what you guys got too? 340? So that's another way that you can do. You do use your calculator. The only downside is that you If you're wrong, you get no method point. So, all right.
Make sure you're plugged.
Now let's do D. It says estimate the annual income of a family whose weekly grocery bill is 100. Okay. 100 pounds. This time, what am I doing? I'm setting is equal to 100 because I'm solving for X. Now your calculator does not do the other way. Like this one is going to have to be done by hand using our good old two-step equation. Yes? How do I solve this? Add 56.7 and then divide by 4.18. And I get that my income, if I have a grocery bill of $100, should be about 37.5 thousand pounds.
Is it okay for us to write like that, or do we actually have to write out like 37
Either one. Now, real quick, is that an interpolation or extrapolation? It is. That one would definitely be an enter. So when it says to comment on whether the estimates in D or E are likely to be reliable, D would be. Ooh.
No.
Oh, sorry. Yeah.
It's C and D.
Sorry, it should be C and D. So I get for copying and pasting. All right. So D, when it asked me for my annual income, that would be. It would be reliable because it's an interpolation, but C is not reliable. And that is how you do it using your calculator. Okay? That's how you find the regression equation with your calculator, and that's before we were doing it using by eye. But that's it.
So is it interpolation or
I say interpolation. That's just me though. Because so just to recap, when you are trying to find your line of best fit by eye, you find your mean for your X and your Y data, you plot that point on your scatter diagram, and you draw your line of best fit so that it goes through the mean and half your data is above the line, half your data is below the line. Remember, anything between your poles, which go from your lowest point to your highest point, anything in between that is called a what? And anything outside of that is a what?
extrapolation.
Okay, so then remember the line of best fit is not consistent, so we use the regression line, so then that way we all can end up with the same consistent answer that is going into our calculator after we type in our data, going to stats, over to calc, and which option?
4.
Lin Red. And so then that's how we get our regression equation. Any questions?